Hi there guys, so today we're now going to look at reciprocal functions. Now what this means is, don't know what happened there, is graphs like this one. Now you may remember from your previous studies that it has a little bit of a look like this. Now if you actually put some numbers in, this is much easier to explain. So let's say x is 2. So when x is 2, 1 divided by 2, well, that's going to be a half. When x is 1, 1 over 1 would be 1. When x is a half, that'll be 2. So what I'm saying here is when x is 2, let's say this is a half. When x is 1, this one's 1. When x is a half, it's going up. If x was a quarter, it'd be 4. And the same with the minuses. That's how we have this sort of shape. So what we basically say is, as the x value gets bigger, and let's say infinitely big, the y coordinate will tend to 0, but it will never meet this 0. It will never hit this line, because no matter what you divide it by, it's always going to be above 0. If it's 0 there, like 1 divided by 0, we say that's undefined, so it's unplottable anyway. So that's why it never actually meets it. And the same this way. So as x tends to the minus infinity, so in this direction here, then also y tends to 0. It will never ever meet this line. And we can say the same for the y. So as y, as these parts goes towards infinity, as this gets bigger and bigger and bigger and bigger, this line will never go vertical, but it just won't ever reach this y-axis. So we say the x tends to 0, and when y tends to negative infinity, so when it's coming down this way, again x will tend to 0. This line here will never ever touch that line. And we call that an asymptote. And sometimes, I'll write that down, this is what we call it, an asymptote. Let me just make sure I'm spelling this right. Yeah. So what we sometimes do is this. We put a dotted line to say where that would be, and this would come a lot more obvious when we come to use transforming reciprocal graphs. Now you might have seen this graph, a similar one as well, when you did trig graphs. So this is like the tan graph. If you think the tan graph, it goes like this. It's kind of a mixture between the cubic graph and the reciprocal graphs, and we say there's an asymptote there. Okay, so let's have a look at some. So it's pretty easy, to be honest, what we're going to ask you to do with these. You shouldn't find this too hard. Oh, actually, before I move on, I will just say that that's y equals 1 over x. So if we were to ask to draw this one, and whenever I see this, I always go back to my quadratic graph. So that being x squared, and this one being minus x squared. So it means when there's a minus, it reflects it in the x-axis. So where we had this before, minus 1 over x is a reflection in the x-axis. So this one is now going to be there, and this one is going to be there. Okay, so it's very important actually, and probably very easy to remember what that one and this one looks like. It will help you massively with these questions. So on the same diagram, so let's draw a diagram. Put our labels on, x and y. So this one I'm going to do in purple, and this one I would do in the pink colour. Now let's just choose a number for x. So if you imagine x to be 1, so when x is 1, let's say here, this one, 3 divided by 1, that's going to be roughly there, and this one's going to be right up there. If we choose 3, I'm choosing these numbers because they're both divisible. So if x is 3, let's say there, this one's going to be 1, and this one's going to be 4. So what you should be able to see is this first one is going to be like that, and therefore like this. So when I come onto this, the second one, this one here on the right, whatever number I put in there is going to be the y value is going to be higher than the one on the left. So it means that it's going to be the same graph, just a bit higher up, and obviously a little bit lower too. And that's basically it. So if I was to put in like a -1, I would get -3, and I'd get -12. So reiterating what I've just said. So that's all we're looking for. Now let's draw my axes again. X and Y. So it's minus, so we know it's going to be like this, but -2 over x and -8 over x. So do exactly the same thing. If you were to put like a 1 in here, so let's say it's there, let's say that's 1, -2 divided by 1 would be -2. Let's say it's there. -8 divided by -1 would be down there. Let's put 2 in now. So -2 divided by 2 would be there, and -8 divided by 2 would be -4. So you can see that this one here, which I'll do in purple, is going to be like that, and therefore like that, and this is going to be a much bigger value, so it's going to be down here like this. Essentially, however, ignore the negative for a minute, but if this is number's bigger, it's going to be further away from the axes. So the smaller the number, the closer it is to the axes. And that's basically it. It's pretty simple. So have a go at some of those.